Okay, let's talk about some more cell phone DC electronics. This is part 4, Kirkhoff's voltage and current laws. This one is pretty simple. Basically, all it means is that the sum of the voltage of the circuit is equal to 0 by the time it ends its course through the circuit. So essentially, in this schematic, all of your voltage would drop across the R1 resistor, and anything on the right side, all the way down that line to the ground point, all the way to the negative side, would equal 0. All of your voltage coming off the battery on the positive side is being dissipated through that one resistor. So if you had a few resistors next to each other, each resistor would drop a voltage. And essentially that means that your resistors each are helping each other resist the voltage, resist the potential that the one pole has to the other pole in exchanging its electrons. And those resistors are dissipating some of the power as they do it. Each resistor does it, has a role in it. And the bigger role it has depends on the size of the resistor. So if R1 is 100 ohms, there might be an R2 that's 1,000 ohms. And so you could do a mathematical equation to figure out how much voltage is being taken by the first resistor and how much voltage is taken by the second resistor. So to think of it as how much, if you were to go back to the sports analogy, the sports, going to watch a sports game, going through the gate, if one resistor is bigger than the other, essentially one gate is bigger than the other. And so one gate is probably doing more work, passing more voltage through it than the other. So one of them might be the VIP gate and one might be the public gate. And the VIP gate isn't going to pass as much voltage or have as big of a voltage drop as the other gate. So in that sense, once everybody gets through the gate, then you reach a 0. So Kirkhoff's current law is essentially the same thing. Each component has a certain amount of current through it until it reaches that ground point and essentially reaches 0. And why this matters in electronics, or I'm sorry, cell phone electronics, is that if you pass a voltage to a ground plane and you look further in the circuit, you should also not see, you should see a voltage drop. Each component should be doing its job, is essentially what it means. Each component, even though current is harder to measure from outside the circuit, each component should have a voltage drop. And if it doesn't, then essentially that component could be something like either failed, shorted to ground, opened, something along those lines. You shouldn't reach a 0 point until the very end when you reach your negative pole. or your ground pole.